Welcome back everyone. Today, we are delving into the world of generative AI and its ongoing evolution. You may have noticed that despite the impressive capabilities of generative AI, there's often a noticeable delay when interacting with these models. This is because they require an incredible amount of processing power, especially when creating complex outputs like images or videos. These models have to take into account multiple factors and perform complex calculations to generate their responses. This process, known as inference, can be time consuming and resource intensive. Let's take a look at an example. Imagine we want to use a generative AI model to create a realistic image with multiple objects, lighting effects, and textures. This demands a lot of computational power, and as models get larger and more intricate, the time it takes to generate outputs can increase significantly. This delay in inference speed can impact the user experience, especially when you have multiple users trying to access the model simultaneously. So, how can we address this challenge? Well, researchers at NVIDIA have identified this very issue and are working on accelerating the inference speed of generative AI models. They have introduced the NVIDIA TensorRT Model Optimizer, a library of advanced optimization techniques to reduce the memory footprint and speed up inference without compromising accuracy. Current model optimization methods often fall short when it comes to techniques like post-training quantization and sparsity. That's where the TensorRT Model Optimizer comes in. It provides comprehensive support for these advanced techniques, ensuring efficient and effective optimization. One of the key advantages of TensorRT Model Optimizer is its ability to handle post-training quantization or PTQ for short. With PTQ, we can reduce the model's complexity and speed up inference. For example, using int4 AWQ, we were able to fit a Falcon 180 billion model on a single NVIDIA H200 GPU. That's incredible. Now, you might be wondering how accuracy is maintained, especially when using lower precision format. This is where quantization-aware training or QAT comes into play. By integrating QAT with popular training frameworks, they have achieved 4-bit floating point inference without compromising on accuracy. The model optimizer also employs post-training sparsity techniques, further speeding up the process while preserving the quality of the generated outputs. The results speak for themselves. Through rigorous benchmarking, the NVIDIA TensorRT Model Optimizer has shown significant improvements. For example, with the Llama 3 model, they achieved a 3.71 times speedup using int4 AWQ compared to FP16. As you can see, the optimizer delivers faster inference speed without sacrificing quality when it comes to image generation. NVIDIA Int8 and FP8 produce images that are almost identical to the FP16 baseline, all while speeding up inference by 35 to 45%. In summary, the NVIDIA TensorRT Model Optimizer is an exciting development addressing the need for accelerated inference in generative AI. By leveraging advanced optimization techniques and integrating quantization-aware training, developers can now create more efficient models that provide faster, smoother experiences for users. Thanks for joining me today. Don't forget to like and subscribe, and stay tuned for more fascinating insights into the world of AI. See you soon.